Now, absolute value function, you have learned the function before in chapter 2, where the function include modulus sign. Alright, there are two cases of absolute value function. First, where it involves only positive modulus. Okay, how do you sketch the graph? Right, first step, what you need to do is you need to take the function inside the modulus and equal to 0. This step is to find the coordinate of the bucu of the absolute value function. Contohnya di sini x equal to 0, and then because we are dealing with coordinate, we need the value of y. How to find y? Just sub back the value of x into the function itself. Fx equals to modulus 0, which is still 0. So the coordinate of the vertex or the bucu is 0, 0. So here is the point of the vertex. Okay, and then because outside the modulus is a positive, so dia macam pembahagi ya. You tarik satu belah kanan ke atas straight, okay, macam ini, and then satu lagi belah kiri you tarik ke atas kiri sini. Okay, itu kalau modulus x. For the second case is where there is a negative sign outside the modulus, like yeah. But the step are the same. The first step, we take the function inside the modulus and equal to 0. Why do we need that step? Because we need to find the coordinates of the vertex of the graph. So here when the x0, we sub the value of x0 into the function back. Fx equal to negative modulus 0, which is still negative 0 or 0. So the coordinate for the vertex of this graph is still the same, 0, 0. But the difference is only because at the step 2, when we need to sketch the graph, since there is a negative sign outside the modulus, we need to sketch downwards like here, but still the same shape, which is V. Okay, for the domain absolute function, most of the cases are from negative infinity to infinity. But for the range, you need to be very careful. Look carefully at the graph. Okay, as for example, for this case, you can see domain for range kita bergerak dari bawah ke atas. Jadinya dari sini, dari negative infinity, they stop until 0 because atas 0 there is no graph. Do you understand, everyone? If you understand, go to the example untuk mahirkan awak lagi ya. Baik, untuk yang ini sama juga, tidak kisah kalau awak faham, if you understand completely what are the steps, only 2 steps required. for you to sketch the graph. Contohnya yang ini ya. Apakah stepnya? Step pertama tadi, first step, you find the coordinate of the vertex. So here, take x plus a equal to 0. So x equals to negative a. The value back into the function modulus negative a modulus negative a plus a 0. So the coordinate of the vertex is negative a 0. So here is the location of the point. And then the step for the step 2, the second step, because outside of the modulus is positive, so you just bentukkan dia bentuk macam V, tarik saja. Itu saja, 2 step sahaja untuk sketching the absolute value. Same also for this example. Okay, for this example, the first step should be x equal to 0. Ambil yang dalam modulus sahaja ya, luar modulus jangan ambil, kita ambil dia. Okay, and then sub balik fx equal to modulus 0 plus a. So dapat a. So that's why coordinate of the vertex is 0 a. Fx is the value of y. And then same, because the modulus is positive, you tarik bentuk v ke atas. Faham? Alright, for this example, fx equals to modulus x plus 3. Sketch the graph and then we need to find the domain and range from the graph. Okay, first step, what is it? Find the coordinate of the vertex. How do you find? First of all, you take the function inside the modulus, x plus 3 equal to 0. So x equals to negative 3. That's not it yet. After that, you need to substitute the value of x equals to negative 3 into the fx back. So f negative fx equals to negative 3 plus 3, which is 0. Here is for f negative 3. Right, jadi koordinat untuk bucu atau vertex for this function is negative 3, 0. Jadi you boleh dah sketch terus untuk ke step 2. Okay, here negative 3 is around here and then 0 is around here. Okay, itu bucu. Jadi untuk menentukan sama ada kita tarik V ke atas atau V ke bawah, terbalik, kita tengok luar modulus adakah dia positif atau negatif. Disebabkan dia positif untuk function ini, dia V ke atas. Faham? Okay, jadi di situ you can determine or control the domain is negative infinity until infinity. And for range, careful, range is at the y value, dari bawah ke atas. Jadi start from 0 to infinity. Do you understand? We go to this example. Okay, fx equals to modulus x minus 2. What is the first step? What is the first step? Do you still remember? Okay, very good. The first step is you find the coordinate of the vertex. Here the function inside the modulus is only x, so just take x equal to 0. Okay, now you only have the value of x. You need to find the value of y. How do you find value of y? You masukkan balik nilai x0 into the function f0. Modulus 0 minus 2, you akan dapat 0 minus 2, which is negative 2. Faham? Jadi itulah koordinat bucu dia, the vertex coordinate. After you get the vertex coordinate, you can sketch the graph. Alright, the coordinate is 0, negative 2, 0, at 0, negative 2 is here. Okay, here is the location. And then you check the modulus. Is it positive or negative? Positive. So, bila positif, dia V ke atas. Faham? Baik. Now, for the domain, from negative infinity until positive infinity. For the range, careful, dari bawah, paling bawah ia adalah negative 2 to positive infinity. That's all for absolute value. Do you understand?
For the next function is piecewise function. Piecewise function is combination more than one function. This function to write in form with curly bracket, and normally every function has limit in x. For example A, given fx equal to negative x squared and x less than 0, and the second is x plus 5 and x greater or equal to 0. That the combination quadratic and linear function. To sketch the graph, I suggest to sketch two graphs separately, and the last we can combine into one axis. Now we divide the table for the two columns. And the first row, we write the interval of x. For x less than 0 and for x greater than or equal to 0. And the second row, we write the function y equal to negative x squared for the quadratic maximum. And the maximum point at 0, 0. And refer the interval of x less than 0. Therefore, we erase on the right graph. And for the second function, y equal to x plus 5. The linear graph and intercept y-axis at 5. At 5, and we can erase on the left for x less than 0. The solid dot. Now we can combine for the two axes, x-axis, y-axis, and quadratic maximum at 0, and the linear intercept y-axis at 5, and the label fx. Therefore, the domain of fx is from negative infinity to infinity, and the range of the function is from negative infinity to 0, not including 0, union from 5 to infinity, including 5. For example B, we have three functions in piecewise function. The first is 2x minus 4 for x greater than negative 4 and less than or equal to negative 1. Second, 3 minus 4x for x greater than or equal to negative 1, less than or equal to 1. And the third is set x for x greater than or equal to 1. Now we divide the table for the 3 column. For the first row, we write the interval of x. First, x greater than -4 and less than or equal to -1. Second, x greater than or equal to -1 and less than or equal to 1. And the third, x greater than or equal to 1. For the first column, y equal to 2x minus 4, the linear function. And the graph is intercept y-axis at -4, and the graph is increasing. Next, refer the limit of x when x equal to -4, y equal to -12. And when x equal to -1, y equal to -6. We can plot the 2 points, -4 and -1. Y -12 and 6, -6. We can delete for the unrelated line. Next, for the second function, y equal to 3 minus 4x, also the linear function. And intercept y-axis at 3, and the graph is decreasing. Refer the limit of x when x equal to -1, y equal to 7. And when x equal to 1, y equal to -1. X -1, y is 7. And when x equal to 1, y equal to -1. And we can delete for unrelated line. For the third function, y equal to set x, the graph set. And the starting point for the graph set at 0, 0. And refer the limit x greater than or equal to, or x equal to 1, y equal to 1. x1 and y1. You can erase the unrelated line. Now we have the 3 separate graphs. Now we can combine the graph into one axis. The value of x -4, -1, 0, 1, and the value of y -12, -6, 1, 3, and 7. For the first graph, from -12 for y to 6 to -6. And the second, -1 to 7. For the second graph. And the third is graph set when x equal to 1, y equal to 1. And increasing. And the label is fx for the piecewise function. Therefore, the domain of the function is from -4 to infinity. The graph is continuous to infinity. The range of the function is from -12 to -6, including -6, and continue to 1, including -1 to infinity. That's all. The end of lesson 2. Given the exercise, sketch the graph of the following functions, hence state the domain and range. Given fx equal to 2 plus x minus 1, and question B, fx equal to modulus x plus 1. You should try to solve this question and discuss with your lecturer. Okay? Thank you.
For reciprocal function, since here x cannot be 0, so the graph will not cross x equal to 0. And since it's positive, so the shape will be like this. And for the value of y, it will not intercept y equal to 0. For A, x cannot be 2. So the graph will be not intercepting the x equal to 2, or we call it as vertical. Then since it's positive, so the graph will be like this. So the domain is like this, and the range is any values, but y cannot be 0. Then for this example, x cannot be -1. So here -1, and then since it's negative, so the graph will be like this. So the domain will be -infinity, x cannot be -1, and the range will be -infinity, infinity, y cannot be 0. Understand?